Welcome to Mechanical Drawing and Design N6. Today's presentation is a continuation on the presentation that I did on CAMS. So if you haven't watched that video yet, you are welcome to go and do that. It is free and available on YouTube. It's wise to begin by watching that video before you come to this one, because in this video I am just going to assume that you already have the knowledge from the previous video on this module. Okay, so don't just begin by watching this video. Go and watch the previous video that I made on the same module. It is available on YouTube. It is free. You can watch that before you come to this video. And so in this video, what I am going to do is just look at another example on CAMS, something that is very important for you to be able to understand, because generally when you get a question on CAMS from your exam, it will look somewhat this way. So I thought it was very important for me to also tackle an example of this nature on top of the two examples that we did in the previous video. Let's begin. And so this is the example. The question says, a motor is turning pinion A at a rate of 1000 rotations per minute. Pinion A has 25 teeth and drives gear B, which has 40 teeth. Okay, so this is pinion A here. Okay, this is pinion A here. It is connected to a motor, and the motor is spinning this pinion at the rate of 1000 rotations per minute. And then you are told that pinion A has 25 teeth and it drives gear B. This is gear B at the bottom, which has 40 teeth. Okay, so now gear B and the cam, okay, the cam is here and this is gear B. So gear B and the cam are mounted on the same shaft. Okay, that's easy to see when you look at the figure, because this is gear B, this is the cam, and you can see that they are mounted on the same shaft. Now the follower has a mass of 120 kilograms. So if you do not know what is a follower, you need to go back and watch the previous video, because I explain all of these things in detail in that video. Okay, so here I am just going to assume that you already have that kind of knowledge. So the question says the follower has a mass of 120 kilograms. Okay, and so the follower is here in the figure. Okay, this thing that looks like a T, okay, that is the follower. This thing here that looks like a T is the follower, and it's got a mass of 120 kilograms, and its maximum fall is 30 millimeters, and that corresponds to a rotation of the cam of 60 degrees. Okay, so the cam will rotate 60 degrees as it causes the follower to fall by through a distance of 30 millimeters. Okay, very, very important. I say it again, if you do not know what is a fall, if you do not understand how the rotation of a cam can affect the displacement of a follower and cause it to fall by a certain distance, you need to go and watch the previous video. Okay, here I am just assuming that you already know and understand all of these things. Okay, so the question says a maximum fall of 30 millimeters of the follower corresponds to a rotation of 60 degrees of the cam. Okay, so now the spring lifting the follower, this is the spring here. Okay, the spring lifting the follower has a stiffness of 160 newtons per meter. So the stiffness of this spring is 160 newtons per, not meters, newtons per millimeter. Okay, you always need to be careful when you are reading the unit for the stiffness, because that will affect your equation for the force that is arising in the spring. Okay, so be careful here. When it's given to you in newtons per millimeter, you need to take note of that. Okay, so this here is 160 newtons per millimeter. That's the stiffness of this spring. Now, the coefficient of friction between the cam and the follower is 0,1, okay? So you can also see here a side view of what we have here. And the coefficient of friction between the cam, this is the cam here, and this T is the follower, okay, and you can see the spring and the slider or the guide here. And so the coefficient of friction between the follower and between the cam and the follower, okay, is 0,1. So as they interact with each other, there is a coefficient of friction there of 0,1, okay. And also you are told that the frictional force between the follower and the guide, okay, is 300 newtons. Okay, so you also have a friction force between the follower and the guide. As you can see here, the follower is sliding through the guide. Okay, and so as it is sliding through the guide, there is friction between the guide and the follower, and you are given that friction force. It's got a magnitude of 300 newtons. Okay, so now they say you can neglect the mass of the cam and calculate first the force that is exerted by the cam on the follower so that the follower could fall with maximum displacement. So we're trying to find the force that the cam needs to exert on the force that the cam needs to exert on the follower to cause it to fall by its maximum displacement, its maximum fall, which is 30 millimeters. For question number 2, you need to find the rolling resistance between the cam and the follower. Okay, the rolling resistance is the same thing as the coefficient. It's the same thing as the friction force. Okay, the rolling resistance is the same thing as the friction force. And so we need to find that. That is the friction force between the cam and the follower. And then finally, for question number 3, you need to find the power that is provided by the cam. Okay, very important and very interesting question. So we're gonna look at how you go about solving this question. If you feel the need to pause the video here, you are welcome to do that, just so you can read the question again and try and understand as much of it as you can. So let us go into the solution. So for the first part of the question, okay, question number 1, what we have to find is the force exerted by the cam on the follower, okay? So if we draw the cam system that we have here, this is what we will have, okay? So this is the cam, you can see it here, you will see the spring there, you see the guide here, and you also have the follower, okay? The follower is this thing that has got a shape like T, okay? This T-shaped thing here that you see is our follower, okay? And so we need to find the force that the cam is exerting on the follower to cause it to fall by 30 millimeters. So basically, when you look at this figure here, for the cam to cause the follower to fall by 30 millimeters, it needs to exert a force that is pointing down, okay? So the force of the cam that we're trying to find is that force here, okay? We're trying to calculate the force that the cam needs to exert on the follower so that the follower will fall by 30 millimeters. But now, to be able to determine this force, we need to establish all the other forces that are present in the system. So now, when you read the question here, you are told first that the follower has a mass of 120 kilograms. So since the follower has a mass of 120 kilograms, it means that it will have a weight, okay? So the weight of the follower is also a force in the system, and the weight is always pointed directly down. So I said the follower is this T-shaped thing that you see here. So it's got a weight, so its weight will be a force that is pointing down, and we can calculate it directly because we know the mass. So the weight of the follower will be equal to its mass multiplied by the acceleration of gravity. And so if you do that, what you get for the weight of the follower is 1,177.6 0.2 newtons. That is the weight of the follower. So when you continue reading the question, you find that you also have a force in the spring, because we are told that the spring that lifts the follower has a stiffness of 160 newtons per millimeter. So now you can imagine that here you can see you have a spring here, and then you apply a force. Okay, this is the force from the cam. You apply that force on the follower and cause the follower to go down. That will cause this spring to be compressed. And so because the spring is compressed, naturally it will exert a force as if to push the follower up, okay, because it will try to resist the force from the cam. Okay, if you have a spring and you compress it, you will feel that there is a force that the spring is exerting towards you because it wants to be decompressed. Okay, and so in this case, since the follower is pressed down, okay, it will compress the spring. Therefore, the reaction of the spring will be in the opposite direction. So the force that is arising from the spring will be in the opposite direction. Okay, that's why I drew this blue arrow pointed to the top. Okay, because it has to oppose the direction of motion as we are compressing the spring. And so to get the magnitude of the force that arises in the spring because of the deformation of the spring, we will use the general equation that we know when we're dealing with springs. To be able to calculate the force in the spring, you just need to multiply the stiffness of the spring by the elongation or the compression of the spring, okay? Because if you stretch a spring, it will exert a force to go back to its original state. If you compress it, it will also exert a force to push everything so that it goes back to the original state. Okay, so in this case it is a compression of the spring, so the x here is the distance by which the spring is compressed. And so since the force in the cam is causing the follower to fall by 30 millimeters, therefore x is going to be 30, okay? And k here is the stiffness of the spring. And now the stiffness of the spring is given in newtons per millimeter. That means, therefore, that the deformation of the spring can be in millimeters, okay? So you can plug in numbers like that, okay? You can use a stiffness in newtons per millimeter with a deformation in millimeters. If the stiffness of the spring was given in newtons per meter, then you will need to have a deformation in meters, okay? So the units must be consistent. If the stiffness of the spring is in newtons per millimeter, the deformation that you have in this equation must be in millimeters. Or if it is in newton per meters, then the deformation that you will have in this equation will have to be in meters, okay? In this case, I decided to leave it in newtons per millimeter and using a deformation in millimeters, and that will give me an answer in newtons. But if you don't understand that, you are welcome to convert everything to SI units. You will still end up with the same answer, okay? If you convert 160 newtons per millimeter to newtons per meter, you will need to multiply this by 1,000. And then this here, which is in millimeters, if you convert it in meters, you will divide by 1,000. So at the end, you will still get the same answer. But suffice to say that if your stiffness is in newtons per millimeter, you can just use your deformation in millimeters. Okay, if your stiffness is in newtons per meter, you can use your deformation in meters. It's fine. Okay, so the force in the spring is therefore calculated like that, and you will find it to be 4,800 newtons. After the force in the spring, you are also told that you have a frictional force that is between the follower and the guide. Okay, so this is the guide and that is the follower. So as the follower is sliding through the guide, you have friction between the guide and the follower. And because the follower is going down, we know that the friction force always opposes the direction of motion. Therefore, the friction force between the follower and the guide will have to be pointing up because the follower is going down. And so that is that force that you see there. And this one, we don't need to calculate it. Its magnitude is already given as 300 newtons, okay? So that is the friction force between the follower and the guide. Now, if you do this, you have all the forces in the system that you need to be able to find the force that is exerted by the cam, okay? And so to be able to do that, you will just remember equilibrium equations where we say that the forces that are pointing down must match the forces that are pointing up. And so in this case, the forces pointing down is the force from the cam and the weight of the follower. And the forces that are pointing up is the force the reaction of the spring and the frictional force between the guide and the follower, okay? And so you will write your equation like that, and filling in the numbers, this is what you get. And from there, it's very easy to find the force that is exerted by the cam, okay? And that will be 3,922.8 newtons. Once you have the force exerted by the cam, you pretty much have solved question number 1. Now, for question number 2, you need to find the rolling resistance between the cam and the follower. And that is just the friction force between the cam and the follower. And now, if you think about it, you will remember that to find the friction force, you need to have a normal force. Okay, so that's question number 2. We know that the friction force is equal to the coefficient of friction multiplied by the normal force. Okay, we have the coefficient of friction between the cam and the follower, which is given as 0,1. So now we need to find the normal force that is acting on the follower. But if you think about it, if you look at this carefully, you will see that that normal force is just the force exerted by the cam. Okay, that is the normal force on the follower. Okay, so N is the force exerted by the cam. Okay, so now to find the rolling resistance, which, as I said, is the friction force between the cam and the follower, you will just use this equation, knowing that the normal force acting on the follower, okay, from the cam is just the force exerted by the cam. Okay, the force exerted by the cam is the normal force. So plugging in the numbers into this equation, we know that the coefficient of friction is 0,1. What you get is this, okay? So the friction force or the rolling resistance between the cam and the follower will be 392.28 newtons. Now, question number 3, we need to find the power that is provided by the cam. Now, to find the power provided by the cam, this is the equation that we're going to use. Power is equal to 2 pi nt over 60. So now, in this equation, therefore, we will have to find N and to find T. Somebody may be tempted to say that N is already given in the question because we are told that there is a motor that is rotating pinion A at 1000 rotations per minute. But notice it's pinion A that is rotating at 1000. The cam is not on the same shaft as pinion A. The cam is on the same shaft as gear B. So we need to find N for gear B, and that will be the same N that we can use for the cam, okay? Because the cam is on the same shaft as gear B, okay? And so to be able to do that, you know that you are given the number of teeth of pinion A and of gear B, okay? You have the number of teeth, so you can relate their RPMs using this equation, okay? The RPM of pinion A multiplied by the number of teeth of gear A is equal to the RPM of gear B multiplied by the number of teeth of gear B. Okay, T here is the number of teeth, it's not torque. And if you wonder where this equation is coming from, I will advise you to go and watch my presentation on spur gears and gear drives. I explain in details how to derive these expressions and how to use these equations, okay? Here, I am just going to assume that you are already familiar with that. And so we can quickly plug in the numbers in this equation, and we can find that the RPM of gear B is 625 rotations per minute. Okay, so this is what gear B is rotating. This is the frequency of rotation of gear B, and because gear B and the cam are on the same shaft, therefore this is the n value that we will use when calculating the power provided by the cam. Okay, so now the next thing we need to find now to get the power is the torque. Okay, and this is where many students begin to get confused. Basically, you need to remember, first of all, that the work done can be calculated using force multiplied by displacement. Okay, this is an equation that you know from engineering science. Okay, but sometimes you have a force that is acting along a circular path. Okay, you can have a situation where the force that is applied is acting along a circular path. And so when that is the case, then the displacement become an arc length. Okay, so if you know that the force moved along a circular path through maybe an angle theta, then you can find its displacement, which will be the arc length that is subtended by that angle theta. Okay, and so S, therefore, the arc length covered by that angle theta, okay, is equal to r multiplied by theta. Okay, this is all from engineering science. And so the work done can also be written like this. This is when you have a force that is acting along a circular path. Okay, so if it is acting over a given arc length, okay, or over a given angular displacement, okay, then you can find the work done using this equation. R multiplied by theta is just the arc length that is covered when we move through the angular displacement theta. Okay, and this is what R times theta is. Okay, it's just S. Okay, and r, of course, is the radius of the circle. And you can also calculate the work done using torque. Okay, so that is the equation that you will use. Work done is equal to torque multiplied by the angular displacement. And so to be able to find the torque here, that we need to find the power that is provided by the cam. Okay, we will need to find the total work done by the cam. And once we have the total work done by the cam, we will then come here, use this equation to find the torque. We already know what is the angular displacement because we are told that for the follower to fall through 30 millimeters, the cam rotates through 60 degrees. So the angular displacement is 60 degrees, okay? But of course, in these equations, when you plug in the value for theta, you need to have it in radians, okay? Very important. And so what is the total work done that we need to find? That work done is the work done to overcome friction plus the work done on the follower. Okay, so those are the two main forces that are actually contributing to the work that we need to be able to find the torque. Okay, so the total work done will be the work done to overcome the friction between the cam and the follower, and then the work done on the actual follower to displace it by 30 millimeters. And so to find these, okay, we will begin first of all by the work done to overcome friction, okay? And that will just be equal to the friction force, which we calculated earlier, multiplied by the displacement, okay? Very important. This is the work done to overcome friction. It is given by this equation. And this again should be familiar to you from engineering science. We already have the we already have the force, the friction force between the cam and the follower. So we just need to find the displacement. Now, to find this displacement is not a linear displacement. It is actually an arc length. It is a circular displacement, and I am going to show you why. This is pretty much a side view of the cam, and you can see this is the cam here, and this is the follower. You can see the spring, and you can see the guide, okay? And let's assume that this cam is rotating clockwise, okay? So it's rotating clockwise like this, okay? So this cam is rotating clockwise. You can see the direction of the arrow, okay? So if it is rotating clockwise like that, we can now also then say, imagine the forces that are acting here, okay? And so first we have the force from the cam. This is the force that pushes the follower down. But because the cam is rotating clockwise, you can expect the friction force to act to the right, because if this cam is gonna come this way, the friction that will oppose its motion will be to the right. But now what I want to show you is that this friction force is not acting on a straight line, okay, but rather it's acting on an arc, because if this cam is rotating clockwise, it will describe an arc like that, okay? And as it describes this arc, that will mean that the friction force at different instants will be acting at different places on this arc, okay? Notice that the follower here will be pressed down as the cam is rotating. So when the cam will be here, the follower will have moved down to this point, okay? And so the friction force, the direction of the friction force will now be somewhere here, okay? That arrow will now be somewhere here. So I want you to appreciate that this friction force is actually gonna be acting along a circular path, and therefore the distance covered by that force is actually an arc length. And since it is an arc length, therefore this is the equation that is going to be appropriate for us to use, okay? And so R in this equation will be 60, because that is pretty much, if you think of this as the center of rotation, the radius will be that distance, okay? The radius that describes this circular path, okay? So therefore the radius is 60 millimeters, okay? And so R will be 60, and theta is the angular displacement that the cam goes through for it to push the follower down by 30 millimeters. And that angular displacement is 60 degrees, but we need to have it in radians, okay? So if we plug in the numbers in this equation, this is what we will get, okay? We already have the frictional force. We calculated that earlier. R is 60 millimeters, so 0.06. And then theta is the angular displacement, but we change it to radians. That is what you see happening here. And so if we do that, we can easily get the force needed to overcome friction as 24.648 joules, okay? And then after that, sorry, it's not the force, but rather the work needed to overcome friction, okay? It's in joules, it's work done. Okay, it's 24.648 joules. And so once we have that, we can now find the work done on the follower. And now the work done on the follower, that one is not following a circular path. As you can see, the work done on the follower is done by the force exerted by the cam. And the cam is acting vertically and pushing this follower also down vertically. So this is just a direct application of this equation, because this force will not act on a circular path, but rather it is acting down on this follower and causing the follower to also move down, okay? So the work done on the follower will be given by this equation, and this x that you see here is just the displacement of the follower, okay? And I used the letter x because it also corresponds to the deformation of the spring. Okay, so then we can then plug in the numbers like that, and immediately we get the work done on the follower. And once we have the work done on the follower, we have the work done to overcome friction. We can find the total work done by just adding the two. And so if we do that, this is what we will get. The total work done will be equal to 142.332 joules. And once we have the total work done, we can now use this equation and find the value for the torque. Okay, so torque will be equal to the total work done divided by the angular displacement. This is just an adaptation of that equation. Okay, you will get it like this. And so if you plug in the numbers, this is what you will have. And notice here that I again changed the angular displacement to radians. Okay, always do that. And then the total work done was found earlier, and this is the number, so we just plug that in here, and then you will get the torque, which is this here, 135.917 Newton meters. Now that we have the torque and we already have N for this shaft, okay, the shaft that connects the cam and gear B, okay, N for that shaft is this. Okay, we have the torque. Now we can use the power equation and plug in the numbers to find the power provided by the cam. And if we do that, this is what we have here, okay? And so you will find that power to be 8,895.747 watts, or you can just round it to 8.9 kilowatts. And so that is the power provided by the cam. And so I felt it was necessary for me to show you how to deal with questions on cams that are of this nature. And I hope this video was helpful to you. And so before I finish, I just want to say, when it comes to mechanical drawing and design N6, one big mistake that many students make is that they assume that it is a subject that they can neglect or that they can maybe study lightly because the exam is going to be open book, they're going to have their notes and so on and so forth. But it turns out that in spite of the fact that it is an open book exam, the failure rates for mechanical drawing and design are still high, okay? And for that reason, I will tell you that although it is an open book exam, you still need to study for it as if it were going to be a closed book exam. I always advise students to do that. Study for mechanical drawing and design N6 as if it was going to be a closed book exam. In that way, you will take it as seriously as you take every other subject that is closed book. Do not get fooled with the idea that because it is going to be an open book exam, that you can then relax and you're just going to survive because your notes are going to help you. I have been a lecturer for a long time, and I have seen that when students did not prepare enough, even if you give them open books, they do not really survive. Okay? The open book is only going to be helpful to you if you are fully prepared, because then you know exactly where to go, you know exactly what is what, and it's only when you are fully prepared that it's going to be really helpful to you. So do not take the studying of mechanical drawing and design N6 lightly. Study for it seriously, even if the exam is going to be an open book. Okay, I hope you will take this advice very seriously, because that is a mistake that many students make. So having said that, this is all from me today. I hope this presentation was helpful to you. If you wish to get in touch with me, feel free to contact me using the number in the description. I have many videos available that will be able to help you. And so if you need to have those videos, you can just contact me directly. And I also have notes that I use in my presentations. They are all available upon request. Thank you so much.